the neural network library is Keras. Therefore, from Keras, we need to import the elements to develop neural networks. In this case, the one that initializes the mathematical equation of the neural network is sequential. Within sequential, we can ask to the parameters of the function which require layers. Now, if we get inside keras.tab layers, we can import these many types of layers. In our case, we will work with the input layer and the dense layer. The layers are given within a list. The first one, inputs, we ask to the parameters the shape. What is the shape? The number of explanatory variables that we have in the dataset. In this case, we can ask with the function shape and take the second element, which is 6. We copy and paste it below. Now the following layer, it will be a dense layer, and we need to give a number of units, a number of neurons, that in this case is the number of variables that we want to predict, which is in the y variable, we only have 1, which is the number of accidents. Therefore, units equals 1. We save the object into a variable that we will call model. If we want to see the numbers of the mathematical equation, we can get inside the object and ask for the weights. Parentheses, we execute, and there we get the numbers of the mathematical equation, which are in WV1, WV2, that given the speed in alcohol ins losses, the mathematical operation is computed and we calculate the predictions for the number of accidents. We will save the weights in a variable. Even though we haven't yet optimized the numbers of the mathematical equation, can we calculate the predictions? To find the function that calculates the predictions, we need to look inside the Python object where we have the model. We access the functions with the dot tab, and now if we would like to calculate predictions, it is normal that the function that calculates the prediction has the name predict. We use the function, ask to the parameters, they ask for the x, that in our case we have it on the x variable, we pass it to the function, execute, and there we get the predictions. We will put it in the same array with the function flatten because later we will compare these predictions after optimizing the mathematical equation. We save them into a variable, and now it's time to compile and fit the model. In the machine learning system, we always follow the same procedure. We create the instance for the model, in this case the sequential, then we compute the numbers of the mathematical equation with fit, calculate the predictions, and calculate the score. For neural networks, there is an intermediate step which is compiling the model, because we need to specify how we will optimize the numbers of the mathematical equation to minimize the error of the model as soon as possible. In this case, you can see stochastic gradient descent, ADA grad, ADA delta, RMS prop. Some of them goes faster to the minimum point, the minimum error, whereas others stuck here at the beginning of the visualization, such as the stochastic gradient descent, which is the worst optimizer. We will get into the details of these parameters in a future tutorial. Now everything you need to know is that in the model we look for compile, they ask for optimizer and loss. We use the default value for the optimizer and the loss will be mean squared error. Now we look for the function that optimizes the numbers of the mathematical equation, fit. They ask for x and y. We pass them, execute. The error is very big because we have only computed one epoch. In the previous case, we computed 500, so that the error is minimized until a very good measure. In this case, 12. Now, if you don't want to see these outputs, you can use the parameter verbose, and instead of auto, you will put A0. Now that we have optimized the numbers of the mathematical equation, if we ask for them in getWeight, we will observe that they are different from the weights we saw at the beginning. For example, the last weight was 0 and now is minus 0.37. Now if we calculate the predictions and compare them with the reality in a table, we can observe that they are far better than before fitting the numbers of the mathematical equation. And finally, once that we have calculated the predictions, which are in the fpred fit after, we see how distant they are from the reality, which is on the y, which is only the difference, and we call it the error of the model. We create a new variable. Since I don't want to have an error for each of the rows, I want to have one error for the model. I need to summarize the error for all of the observations. Nevertheless, I have errors negative and positive. If I want to add them up, I need to calculate the squared error. Now we create a new variable that will be called error squared. And finally, we calculate the average error with the mean. Now, instead of having done this manually, we could have used a function from the model, which in Scikit-Learn we normally know it as the score. Nevertheless, in TensorFlow, in the Keras library, we don't have it. We have evaluate. We ask for the parameters x and y, we pass them, and there we see the same number, the same error. In conclusion, which are the similarities and the differences between deep learning, the neural networks, and conventional machine learning, such as the linear regression? The ultimate goal of machine learning is calculating the predictions for a variable which is known to have the real data. Both the linear regression and the neural network calculate the predictions. The system that they follow is the same because they are machine learning models, machine learning algorithms. In Keras, we create the instance for the model and then we follow the machine learning system, fit to compute the numbers of the mathematical equation, predict to calculate the predictions with the mathematical equation, and evaluate to compare the predictions to the reality. In Scikit-Learn, the functions are the same, fit, predict, and score, which in this case is the one in Keras evaluate. In the theoretical aspect, we observe how both algorithms start with the historical data and try to compute the best numbers of a mathematical equation. Both of the models evaluate the predictions with the reality, which is the error, and then they create the curve for the error so that they can find the minimum error with the best numbers of the mathematical equation. What is the difference nonetheless? That in the linear regression, to find the minimum error, we can just compute the derivative and equal it to 0. Nevertheless, in the neural network, we have more than one minimum. That's why it is not possible to just calculate the derivative equals to 0 to find the minimum error, because we have more than one. Therefore, what we do in neural networks, which is a deep learning model, we start at one point, calculate the derivative, which is the tangent line in the point, and then we will move the point, the number of the mathematical equation, until we converge to a minimum error. Because we involve many iterations, we call these algorithms deep learning. Now that you understand how simple it's deep learning in terms of the machine learning system, you may be wondering which is the quid of the neural networks. why the hype with these models? Where is the complexity of the neural networks? I will explain it to you in the following tutorial.